Hi everyone, in this quick video I'm going to go over a sample CFA problem in Excel that will help you understand the difference between arithmetic mean and geometric mean. Let's get right to it. So suppose there's a portfolio of non-dividend paying stocks that earned a geometric mean return of 5% between January 1st, 2017 and December 31st, 2023. You're also told that the arithmetic mean return for the same period was 6%. If the market value of the portfolio at the beginning of 2017 was $120,000, the question is, what was the market value of the portfolio at the end of 2023? Basically, if you take a look here, if you start at the beginning of 2017 all the way till the end of 2023, that's a total of 7 years. At the beginning of 2017, you're told that the portfolio was worth $120,000, and you've been tasked to find out how much was it worth after 7 years. And so what I've done is that I've jotted down all that information here: the arithmetic mean, the geometric mean, the beginning value of the portfolio, and the total number of years. Fundamentally, this is essentially a question of whether you want to use arithmetic mean or the geometric mean to grow this $120,000 over the next 7 years. And for questions like these, you should always use geometric mean and never arithmetic mean. The reason is that the geometric mean is the true representative of the average compounded annual return that you've earned. So to help you see this, I'm going to do a very simple exercise. So let 0 represent today, 1 represent 1 year from now, 2 represent 2 years from now, and let's suppose today you had a $100, so $100. And let's suppose in 1 year you make a 100% return on your investment, which means that the 100 grows to become 200. But then let's suppose as you go from year 1 to year 2, your investment becomes worth $100 again. If I ask you what is the return that you made as you went from year 0 to year 1, I hope you can see that since you doubled your investment, your return would be 100%. And as you go from year 1 to year 2, notice that your investment has become half of what it was, so you've lost 50%. So these are your returns for year 1 and year 2. If I ask you to calculate now the arithmetic mean, well, that is a simple exercise. You'll say equal to, you'll basically do this plus this number here and then divide that by 2, because that's the very definition of arithmetic mean. And so notice that comes out to 0.25, which is essentially 25%. But would it be fair to say that on an annual basis you earn 25%? Actually, if you take a look at the numbers, you're like, wait a minute, I started with 100, I ended up with 100, I didn't make anything. So growing this 100 at an annual return of 25% would give you a misleading indication of what you end up at the end of 2 years, which is why you don't want to use arithmetic mean. What you instead want to use is geometric mean. And if you recall, geometric mean is essentially calculated as 1 plus R1 into 1 plus R2 into 1 plus R3, like however number of returns you have, and then raise to the power 1 over the number of time periods, and then you subtract 1. Okay, in this very simple setting, that is simply going to be equal to 1 plus your first period return multiplied by 1 plus your second period return, and then all of this is going to be raised to the power of 1 over 2. Why 2? Because 2 is the total number of time periods, or the total number of returns, and then once you have solved this, you're going to subtract 1 from this number. And when you do that math, you get 0%. Exactly, right? You didn't really make anything on average. You started with 100, you ended up with 100. All this to say that a geometric mean is a better representative of the average compounded annual return that you've made. And so in this case, therefore, the worth of your portfolio is going to be equal to 120,000 times 1 plus the geometric mean raised to the power 7. And so the answer is $168,852.05. If you found this video useful, click the like button and subscribe to the channel. And feel free to ask any questions using the comment section. Happy learning!